In this video, we're going to explore beyond numbers and start working with letters and characters with ASCII. So a quick review. Computers are made up of billions of switches. Those switches can be thought of as ones and zeros, and once we know how to count with ones and zeros, we can represent any number we need to do. But that's all just numbers. What if we want to move beyond numbers? So what we could do is just start assigning letters numerical values to work with them. So if I sat you down and said, let's start numbering the letters, you would probably come up with a scheme like A is 1, B is 2, C is 3, and so forth. But then what are we going to do with lowercase letters? How do we want to number those? And moving past that, what if we want to represent other things such as exclamation marks or punctuation? So we're not just representing letters, we're going to represent characters. And so a character is going to be an individual element. That's what we refer to individual letters and punctuation symbols in computer science as characters. So you can imagine if I sat down 10 individuals in a room and said, start coming up with a numbering system to go between characters to numbers, they would all come up with slightly different systems. So in the 1960s, this was a reality. Different companies and organizations were using different numbering systems. So a committee got together and they developed the American Standard Code for Information Exchange, or more commonly known as just ASCII. And what they did is sat down and developed a numbering system to go back and forth between characters and numbers. So this is the system they came up with. It may look a little odd to you. For example, the character A is represented by the number 65, and a space is represented by the number 32. At the time, these were all the printable characters that were being used on teletype machines. And you were probably far too young to know what a teletype machine was, but it was used to communicate between newspapers and government offices and financial institutions to send information back and forth. You'll notice that there are the first 32, 0 through 31, those characters are actually missing. And that's because those were special characters that were specific for teletype machines. So for example, number 8 actually made a little bell or a beeping noise to wake somebody up. And 14 said, advance the paper a little bit. So they had a whole bunch of these special characters called control characters that were used to control a teletype machine and send messages that were other than characters. In today's world, all those characters are pretty much obsolete. Another interesting thing to point out with the ASCII table is this is how alphabetical orders are determined by computers. When you sort things in your folder or in Microsoft Excel, it needs to convert those letters to numbers in order to sort them. So the exclamation point is the first visible character alphabetically. I've seen many people, and you probably know someone like this, who has all their contacts in their phone start with A's, their most important contacts, so they appear at the top of their phone list or their chat windows. I've seen people use AAA mom and AA Bob to indicate that those are the most important things. But what you can really do is start using exclamation points, and that looks a little cleaner. If you are so inclined to do this, I encourage you to use exclamation points. Or if you want your name to appear at the top of your friend's chat window, for example, if you put an exclamation point in the front of your name, you will now appear at the top of their list. That is really great if your name happens to be Zachariah Zimmerman or something like that. So now that we have a numbering system to go between letters and numbers, a question arises is, does a computer really understand what a character is, or what a number is, or what a word or a sentence is? So the hardware of a computer, the CPU, only represents numbers. It's all done in software of the computer that interprets those numbers as letters. The computer has no semantic meaning of words. That is entirely done in software. So in Microsoft Word, when it does a grammar check or a spell check, it really doesn't understand, the hardware itself really doesn't understand what a word or a sentence is. It's just software that strings together a whole bunch of numbers and makes some computation on those numbers and starts to add a semantic meaning. This is very much like how higher layers of communication work. The computer builds on top of numbers and numbers to start having an interpretation of letters and sentences. Now, the ASCII character set did not last very long because we started communicating with Europeans and we needed to represent characters with umlauts and other accents. And so they developed the extended ASCII code, which actually used a full byte. If you notice on the previous table, it actually only went up to 127. So it only needed 7 bits to represent each ASCII code. This was actually important in the early days of computing. So with the extended ASCII set, they extended it to a full byte and they added some extra characters that can be used. But that, again, did not last very long. 256 characters is not a lot to represent communication in today's world. So in the late 80s or early 90s, a larger committee got together and started coming up with how to represent characters from around the world. And the system they developed is known as Unicode. And in today's world, computers that exchange information between countries and different regions of the world use Unicode to express that information. In fact, you can now have websites and URLs that include Unicode characters as well. Now, I would imagine for most of you, the most exciting part of Unicode is that it represents emojis. And if we actually go to the Unicode webpage, we can start seeing all the possible emojis and what their corresponding codes actually look like. So I'm going to just scroll through this page here and show you some emojis that are available. There's actually hundreds of emojis available here. So say, for example, you type into your chat window a big pile of poo. What you're really doing is sending this code right here. When your chat client is saying you want to insert a pile of poo, okay, I'm going to send whoever you're chatting to Unicode 1F4A9. That's a hex number, which gets converted to binary or bytes, and that is actually what gets transferred to someone else. So if you really want to insult someone and you want to do it kind of in the geeky way, you can call them a 1F4A9, which we all know means big pile of poo. Now, one of the problems with Unicode is not all software handles it well. You will often see just a box where a Unicode character will appear because whatever software is being used doesn't fully understand Unicode. This is especially problematic in very poor quality websites where they're stealing information from other websites and copying the information over, and they're not expressing the Unicode properly. So the last thing I want to mention is something known as UTF-8, which you do not have to know a lot about, but I want you to be aware of it. And that is what's used by many web pages to insert Unicode characters into their web page. The idea with UTF-8 is that it's a combination of both ASCII and Unicode. So some characters are just represented in regular ASCII, and you have 1 byte per character, and other special characters are represented in Unicode, and that for those circumstances, multiple bytes are used for each special character. Again, we don't expect you to understand fully what UTF-8 is. You should just be aware that it's a mixture of ASCII and Unicode, and it's used by many websites. So that is how we can go beyond numbers and start representing letters and characters with ASCII and Unicode.